Alright, marshmallows and mallow cups. Could just go through some information tonight. I want to get this on a hard line, see if I can get it up on YouTube. Some information that I bring to the table. Here, this is my Necronomicon, how to reanimate the dead for the most part. I generally use this as a guide to teach gravity, electromagnetism, strong force, weak force, and we'll get into the STEM problems, Rhodes conjecture, Fermat's, Beal's, Riemann's hypothesis on prime numbers, and you'll get more into that information later. I'll break down Schrodinger's equation for you, or parts of it. We'll start to play with it a little bit. Burn coefficients, it's raising to the power of a matrix. If you're this all being a stone mill manual, building into your brain starts as a kid needing everything, but you don't know how the moves really work. So I'm designing a gambit for you here to say we're going to need some pieces, and we're also going to need some points, right? You're going to need some ability of Dirac's equation, Schrödinger, something along those lines. A good perfect square for you, and you could do a 3x3 or a 4x4, whatever, but I just think this works good to the quantum physics. You get your one state, your binary models, chessboard, entropy design, which is, again, anything that we want to scale from the chessboard design to the pieces configuration to any gambit that you might parallel into a moving something around. This is a landscaping, hardscaping, interior design, or moving, or however you want to base the contract into your finances and additions to any metrics that you might add into your value. And we'll get more into this later. This is my chessboard. This is the Knight's Tour Gambit that I provide to you. This is more of a syllabus. And again, we'll be getting more into those syllabuses here in a moment about providing a land nav situation, an algebra integral tool on the back line here, Yang-Mills mass gaps, Sophie Germain on prime numbers, Poncures on topologies, what do we got here? Brick and Sandry's conjecture. So we're going to be getting into these terms. Y, what is C? What is J? What is N? What is K? And we're going to apply that in a form that deals with the sonar, algebra, trigonometry, calculus. We'll go through here and we'll describe these metrics and chaos theory, Couch's theory, some other ideas, and Rhodes being chaos theory. And that's a sigma state, or a sigma wave, if you will. It's how you describe the force of describing the environment to somebody, or its limits. A lot to do with the river, particle designs, or particle movement, ideal states. STEM, very critical. Space of exact energy design, science, technology, engineering, mathematics, and of course SWAG, scientific wild ass guess. This super critical. We'll get more into it, but we're just doing the flash. Command directive, basically any model. We're going to draw these out. We're going to break them down into forms that apply to what we are at the moment, the integration of how you go into the room, high or low. This is actually a stone mill. When you go to fix a saw, power wash something, hardscape, landscape, teach a 8th grade class on the syllabus. We'll continue this down. This is my master makes and walkthrough of a company that I actually did. Day one entry, thermal saw, right down to becoming a head sawyer of their 5-foot gantry programs, where you're going to be in charge of orientation, the ground guy, operator, sawyer, and master mason programs, the angle of the slope. Maintenance logs, service maintenance, preventive maintenance, the difference between ground guy states, sawyer states, and manager states, how you got to go through that, how you orientate yourself to this. This will be the saw program as if it were G code and M code from the ground, because either we need to be able to find a way to integrate this in a 3-ring binder, or we're going to be drawing these out. This floor metrics is actually a floor, treads, pattern, whatever. Fixed cuts in existing protocols. We're going to back drag this as a system. And start here, drag them back. When you're actually in those sites, it becomes a lot easier. The orientations of the blocks, how you need to load them in given the grain of that situation. And of course, any computer fixes that you might need here for a front view, being different views in which you can orientate the system. And again, you'll be seeing much better systems later. Okay, this is actually programming those blocks into the saws. And being a partial derivative of this, we are only looking for the square or the smooth globular states. Hit the big ones, draw it if you feel it's important. Otherwise, usually the term does its good. Organization and position of field theories, NP. Easy to check, easy to look up. Organization of field theories in students, blocks that you have in bays or have access to, cut designs, mechanic numbers, tracking your results. And this is important for a lot of reasons. Day crews, night crews, other kind of systems where you can generalize those models off of into whatever meeting you need to do. As you'll find, M1, M2, MN, an M1 and M2 machine gun, or the Abrams, as it stands into the situation, you're going to need to take this down to the 7 key places that you needed to do. Obviously, this is relative, 0 and 1. Bring a decent resume. Bring one place with all this to it. We can hack this down. Velveteen Rabbit, local azimuths and designs, and we'll be getting much more comprehensive about this later. Military bases, colleges, everything. We can integrate that to, whatever design you want it to be. You want it to be gas stations. You want it to be water treatment facilities. You want to do somebody's local azimuth as a drill sergeant, or just ROTCing patrol. Black book here is going to give you the radials that are most common inside of the situation given the routes you're going to run. But basically your 5 points, 4 points, 3 points. Okay, your day-to-day systems. All right, this is generally what you're going to do. You're going to go in, start from home, bang around, do a bunch of stuff, and just draw it out. Another stone mill I went to. How to grade a rock. And again, these are just going to be open field mechanics, climbing the hill, being a ground guy, an operator, so on and so forth, while you're just picking rock. These are just what we do, is either take field stone or regular stone, fluff it out, and pick it out for grade. It's going to go to the site. It's going to go to the guillotine, some of the guys, and most often you'll be out here keeping track of the thin, thicks, regs, and premiums. Garden path, heavy wall, pallets, system organizations, their routes around the mill, and you're going to be overlatticing that and nesting or latticing the system. It's my 300 IQ checklist. Obviously not comprehensive enough to the level that everybody's looking for here, but it covers the details of what your operation, not being a mechanic in a massive company like that, of what details you're supposed to do inside of the situation, Scale house. This is your scale house rocks numbers. You'll be getting a lot of that with your general cut coefficients in your cut. Not necessarily we're cutting these, but you could. You can do it from other things. How the scale house works, what are the operations. You're just going to go through it all and make sure you nut and bolt mechanic. A general resume, special relativity resume. You're just going to continually run this exponentially out on the run. Small business designs, AR Backyard 150-2 STEM resumes. That these are small business design, invention platforms, work histories, command directives, Joint Chief Staff Dictionary of Terms, syndicate designs, the art of war, and quotes and quatrains. Small business design. Starting here would be a small patent design or an invention that I'm coming up with. Just, it's anything. It's Sigma here. It's pack your chute and get in there. Arm-mounted bow rig with universal tendencies, arrows, nocks, systems, so on and so forth. Give you a basic idea. This is generally the field. You got to climb the ladder, play the game, do the land nav, listen around, fight for it, and hold that air superiority of this classroom, the general's desk, if you will. Any coffee that's on it, what's in it, and generally how to grade an A to an F on this system. Fun art. Good way to look at it. Sign your name in the book. All right, especially when you would think about this. All right. So we got some math parts to this too. Functional analysis, Fermilab spin direction. You got scientific methodology on Aristotelian's common sense physics. I give you a breakdown. However long, you may take 8 years on that. It's not a problem. Ball and air, ball and water, ball and oil. Hadron collider, photon and an apple. Would be based on what apple or atom you have in that field, given the baby in the bathtub, the water. And again, we'll be playing with what is up later, WIMP particles, and a whole bunch of friction of the infinite past and infinite future, given those signals. There's the black body problem, Bernoulli, and the history, NTF beginning, NTF end, how useful it is to where they are today. Yeah, quantrinos and axions, given the system of, well, basically your heart rate monitor at any other given point of Princess Peach's dance here, and twistor theory for the Riemann sphere, Sophie Germain, Riemann's hypothesis. These are periods, they are mods, they are orbitals, they are basically Feynman diagrams by any other standards, and Maxwell-Raylight in genes. Maxwell, if you choose to idealize it this form, not around, I'm not arguing with a headstone. Raylight, Maxwell, genes, Raylight, Maxwell would give you a better comprehensive spectrum on the vibrations, or negative 273 Kelvin to glass out, ice out this situation. The Putnam, okay, here this is about integrals, derivatives, sigma, again, in the term of how we're setting up an arithmetic series to explain the pie chart. The, company command we'll be getting into later as far as rank structures, pays, and models of this ASVAB design. Alice and students on a field trip. Steffi and Jenna living together. Dave borrowing 2,500 for what it is. But we're going to make it a little bit more comprehensive than just the state. We can change multiple features at any point in time and basically make any of these a multi-worlding metrics. Obviously in practice, training in school, against the test in general, the area, distance, ratios are going to be super critical, and we're going to be needing to do them charts. We might even need to compel multiple charts together in certain forms so you have a better idea. And geometry equations, trigonometry forms, most mathematical symbols or functions that you need, a little bit of Hebrew, Roman, and the Aramaic or something, Hindu. Not that this is really necessary, but in case you do find it, as Army do, minus lambda, that's you. Inside here, you can play that game when this is raining down heavy on the lift, or on the bunny shop here, for string theory and how you have to be able to jump this electric fence. We'll be getting into that again against the pi, or the brackets for the BJ of a little delta, again for the radials, how far you're going. Here we got some basic circuitry and stuff like that. How to originally set up to it before you do this. Remember, breadboards, real breadboards back in the day. Now we have different types of breadboards, but the transistor is generally the same. Single stage relays, deep flip-flops, codes, hello world stuff inside of here. I'm running out of time. The bull coffin. right? You know, it's a concrete pour with a Gaussian for the right optics. I'll catch you on the next one.